Hey, it's Mr. Kingsbury, back at you with a little more Algebra 2 knowledge to send your way. Again, our unit is systems of equations, so we're figuring out how to solve those. Today, we're going to use matrices to do a little solving. Of course, that's me. Don't forget to put your name at the top of your notes, the date that you're doing this, and the period that you have me. Our essential question for today is, how do I solve a system of equations using matrices? And I bet right now you guys are wondering, Kingsbury, what's a matrix? Glad you asked. First of all, let's establish that matrix is the singular and matrices is the plural. So there you go. That's good to know. Now, what is a matrix? A matrix is a way to organize. I don't know what Tor is. I don't know. A way to organize information using rows and columns. And they always have brackets. So it'll look something like this. This is what we're going to look at the most. So I'll just go ahead and do one like this. It's what's called a 3x3 matrix. And I'll explain that in a second. It's called that because there are 3 rows and 3 columns. So this is what a matrix looks like. And I would point out that there are 1, 2, 3 rows and 1, 2, 3 columns. So we call this 3 rows by 3 columns, or, if you will, a 3 by 3 matrix. Now, we're really not going to get into matrices too much. There are a lot of things you can do with them. In fact, I took a whole class on matrices when I was at TCU. Go Frogs! It was amazing what we could do with them. We're just going to touch on them briefly. They're fabulous. You're going to love them. There's a bit of setup, but you really don't have to do too much setup to really be able to use them well. So now that we know how to look at these, let's just practice really quick. Let's say I gave you something like this. That has like 1, 2, 3, 5, 7. -1, -2, -3, -5, -7. That's 2 rows, right? And 1, 2, 3, 4, 5 columns. So that'd be a 2 by 5. This is very important. You know that rows come first and columns come second. Now, there's a whole bunch of other stuff we could do, as I mentioned, like adding, subtracting, and multiplying them. We're not going to get into that. We're just going to use the calculator and matrices to solve systems. So let me not belabor the point. All right. When you are given a system, you're going to have to come up with what's called a matrix equation. And it looks like this. There are 3 matrices. The first one is called the coefficient matrix. Coefficient matrix. The next one will be called the variable matrix. And you'll notice these are being multiplied. It's implied that there's multiplication. So they will equal the constant. Actually, I'm not going to call it constant. Let's call it solution matrix. I know you're thinking, where are his brackets? They're right there. So let me see if I can give you an example of this. How about, let's see, something like this. Let's say, example. Say I give you 5x plus 10y plus 12z equals 310. And then the next equation will be 5x plus 5y plus 4z equals 155. And then lastly, we will do 4x plus 2y plus 3z, and that will equal 92. So how do I turn these into my coefficient, my variable, and my solution matrices? It's actually not too hard. It looks something like this. So the coefficient matrix is all the coefficients. So my coefficients are 5, 10, and 12. And then in the next row, 5, 5, and 4. And last row, 4, 2, and 3. And I will put brackets around them. Please note, I kept stuff from the same equation in the same row. And I kept stuff from the same variable in the same column. The x coefficients are 5, 5, 4, 5, 5, 4. The y coefficients are 10, 5, 2. Look, 10, 5, 2. And the coefficients in this first equation are 5, 10, 12. 5, 10, 12. Very important to keep all those things together. Then the variable matrix will be my variables as they appear left to right, x, y, z, x, y, z. There's a reason that we are writing them diagonally. It has to do with matrix multiplication and how that works. I don't really want to get into it because it's not necessary for you to know that in order to use them in the way that we're going to use them. Then lastly, we have the solution matrix. That's just all these solutions. I'm just going to basically write that column 310, 155, and 192. And that is a matrix equation. Not a whole lot to it. In fact, let's go ahead and do a couple of examples, and then we can call it a day, I think. So here we go. Next page. Let me set my notes really quick because I didn't do that beforehand. I never know how many sheets of paper I'm going to need. So I don't always set things up. This reminds me that I need to print out bookmarks for everybody so that they can have something to set theirs up with other than a note card. Anyway, I'm kind of guesstimating here. It's okay. There we go. So example 1. And I'm going to show you how to set up the matrix equation, and then I'm going to show you how to solve it. So probably we'll need to write down the commands. We'll get there. Let's see. So let's just use, that means lunch is over. I only have a few minutes to finish this up. Fortunately, it's my conference period. Let's just use do I want to use the one that we just did? Let's use this one. So let's say minus 6y plus 2x equals 21. The next equation will be 2x plus 3y minus 3z equals negative 9. And then lastly, we got negative 3x plus 9y minus 4z equals negative 24. There we go. So the first thing I'm going to ask is, how does one, or what is the matrix equation? So we'll write our coefficients. Let's see, we've got 5, negative 6, and 2. 5, negative 6, and 2. We've got 2, 3, and negative 3. I really hope that I did this right. I'm copying it out of a book that you can't see. It's off to the side, and you never know. Anyway, and then we got negative 3, 9, and negative 4. There we go. Our variable matrix will be x, y, and z. I like to write my stuff in first and then put the brackets on for the most part. My solution matrix will be 21, negative 9, and negative 24. So there is the matrix equation. Now the question is, how do we solve this? And it's actually on our calculators that we have here quite simple. They've made it even more simple over the years. Back in my day when we did this, we didn't have calculators. Just kidding. That was old man Kingsbury. We have these new ones this year that make it even simpler than it used to be. It used to be fairly simple, but we can take it even one step further. So let me show you. Not that it's going to matter a whole lot to you. So there's this area on the calculator. Let me see if I can zoom in so you can see the word. It's right here. Right here is the word matrix. So a lot of the stuff that we have to do with matrices is right here. In fact, this is the matrix menu. And if you hit second and that button, it takes you to everything you could possibly need to know and see and want to know about matrices. And there is a way to do what we're about to do going in here. In fact, we will start in here. But there's a faster way to put in matrices than there used to be. It used to be you have to go over to Edit, select a matrix, decide how big it was, and then type in all the different elements and so forth. And then you'd have to go back, and if you wanted to do anything with the matrix, then you would have to go back and you would select it from this list, and it was kind of long-winded. Well, it turns out there's a faster way. For us, we're going to go, let me just start from the beginning. We're going to go second matrix. We're going to go to the math menu, and there are a lot of different options here. Some of these things are crazy. This is for the determinant. This is to find the identity matrix. You've got an augmented matrix, all kinds of stuff you don't need to know about. What I want you to do is go down to option B, which says RREF. That's reduced row echelon form. That's a very fancy title for a way of taking a matrix and reducing it down so that there's a diagonal of ones and then zeros everywhere. We're going to use this to solve our system. So we'll select that, and then we need to make our matrix. And there's actually a cool way to do this. Normally you would have had to gone in and already set it up already, but the great people at Texas Instruments have made a much simpler way to do this. I'm going to back out a little bit so you can see what I'm doing. So I picked reduce row echelon for REF. I'm just going to hit alpha and F3. And you see it gives me this great thing that says how many rows and how many columns. We are always going to pick, here we go. I had to go up, 3 rows and 4 columns. And once you have selected that, I want you to go down to OK and hit enter. And you'll notice it puts a matrix that's 3 rows and 4 columns inside the brackets that we had going on there, or the brace, which is awesome. Then we can type in all of our numbers and get a great answer. So here are our numbers, right? Here's what we're typing in. All I'm going to do is go across each row. I'm going to skip the variable, and I'm just going to type these. So 5, -6, 2, and 21. Now you have to hit enter after each one. If you don't, it will not work. If I hit 5 and I don't hit enter, and then I hit 6, I just typed 56, not 5. Oh, I'm sorry, not enter. We want right arrow. Let's try that again. So let me show you again one more time. Second matrix, right arrow to the math, down to option B. I don't know a fast way to get down to there. Hit alpha, zoom. From this point on, it should probably be set, but 3 rows, 4 columns. Okay, let's type it in. We got 5, right arrow, -6, right arrow, 2, right arrow, 21, right arrow. And then you hit right arrow again, and it'll take you to the next row, which is 2, 3, -3, and -9. So 2, right arrow, 3, right arrow, -3, right arrow, and -9, right arrow. Then we got -3, right arrow, 9, right arrow, -4, right arrow, and -24. And once we're done with that, then you hit enter. Once you hit enter, that tells the calculator to go ahead and put the matrix in reduced row echelon form, which looks like this. See how it has a diagonal of ones, and then there are zeros all around, and then there's this one column of answers. Those are our answers. So this is where the variable matrix comes in. So I got x, y, z equals, and see how there's a column, right? There's a column with 3, 1, and 6. 3, 1, 6. And the order tells you that x is 3, y is 1, and z is 6. How cool is that? I gotta love it. I think it's amazing. All right. Now, I've been on this video for almost 15 minutes, so I know it's getting long. Let me do one more example for you. We will do plenty of practice in class. I need to do one more example, though, because there are some things you need to know how to handle. All right. So here's the next example. X plus y plus z equals 10. 2x plus z equals 12. And negative y plus z equals 3. Now you may notice something about this particular system of equations. And what you may notice is there are a lot of coefficients missing. There are even variables missing, like y and x. You may be wondering, how do I handle that? Well, it's not as hard as you think. Let's take this first row. X plus y plus z equals 10. Remember that if we don't explicitly write out a coefficient like 2 here, or like in our previous examples, all of these, right? 5 and negative 6 and 2, those are explicitly written out. If we don't do that, we assume there's a 1. So when I go to write the coefficient matrix, I'm going to write 1, 1, 1. If it helps you, you can put 1s in. There's nothing wrong with that. So we got 1, 1, 1. And then we got the next row. And I got 2 x's and I got 1 z. I don't have any y's though. So now remember, this is my x column, this is my y column, this is my z column. That's how I just set it up from the first equation. So 2 is the x coefficient that's going here. 1 is the z coefficient that's going here. I have no y's. Well, we have an answer for that. There's a number that means nothing, and that would be 0. So we'll put 0 there. Then we have the last row. Again, no x, so I'll put a 0 there. Notice there's a negative in front of this y. I actually put a 1 in there so it looks like a negative 1. That's what we're going to put in. Pardon me. And then there's 1z, so we'll put 1 in there. My variable equation or variable matrix will be x, y, z in one big column, no big deal. And my solution matrix will be 10, 12, and 3. Again, no big deal. And now that I have this, I can type it in my calculator and solve it. So let's practice, shall we? Second matrix, right arrow, down to B, enter. Alpha, zoom. Make sure you've got 3 rows and 4 columns and click OK. And we will type in our matrix now. So the first row will be 1, 1, 1, 10. 1, and use your right arrow, 1, 1, 10. Right arrow again. 2, 0, 1, 12. Right arrow again. 0, negative 1, and 1. Oh, and 3. And then I hit enter. We get that. Not the best answers in the world, I grant you, because they are fractions. That's not fun. Kind of wishing I'd chosen something different. I feel like maybe I did something wrong. I'm just double checking because I feel like I did something immensely wrong here. 2, 0, 100, 0, negative 1, 1, and 3. Huh. Well, I guess I did it okay. So we'll write out our answers. X, Y, and Z equals, I wonder if there's a way to, let's try something. I don't know if this is going to work, but I hit math fraction. Did it work? Oh, it did work. Cool. So X, Y, Z equals 11 thirds, 5 thirds, and 14 thirds. Go me for being halfway intelligent. So let's just write down the buttons really quick, and then I'll be gone because we're approaching 20 minutes. So to begin with, you want to hit, here, let's put our buttons. Second, then you're going to hit matrix, which is actually the inverse key. It's x to the negative 1. But second, matrix, then you want to do a right arrow, then you want to do option B. So you want R, R, E, F. That's not a button you push. That's what you select. I'm going to put select R, R, E, F. Then you hit alpha and zoom. 3 rows, 4 columns. Okay. Type in your data using the right arrow and then hit enter. And you get your solution. There you go. All right. Well, that's all for today, folks. I will see you in class.